is held by your authority. July 1st onwards, they are going to ask them to come, all students to college. That official circular, once we receive, I will share to you. But be ready. From next week, next month onwards, we are going to attend the college physically. Okay? The updated circular. Once official circular will come, I will share you. Just whatever the information I got through the WhatsApp from the HOD, I am sharing. Okay, just now, 12:30 meeting is in that they discuss like that. They are asking to come college, faculty they are asking to come college 28th onwards, and even they told us inform students to attend the classwork physically from next month first onwards. Like that they told me. But anyway, we will get the circular officially from the institute. That circular I will inform once it will come. But just I am giving the information that this is the thing, it will happen. Okay? Please ready. If, mentally you prepare. Once the circular will come, you can plan. Okay? Is it okay?
Okay, sir.
Yeah. Please plan. Yeah. Now, good afternoon once again, all of you. All of you, good afternoon. Hello.
Good afternoon, sir.
Yeah, please.
Good afternoon, sir.
Yeah, we are discussing about transaction management system. In that, we discussed about what is transaction and how the transaction will work. Then when we want to perform transaction, how to prepare the schedules, how to prepare best schedules, and when we are going to perform a transaction, we have serialization techniques. There may be the conflict serializability, view serializability. And nowadays, the serialization of transactions are not right, so that the concurrency mechanism also required. So that for the implementation of concurrency mechanism, we discussed a lot of techniques, maybe the recoverability techniques and rollback techniques. And in the last class, we discussed about the testing for serializability here, how to test the serializability. Just we are going to create a precedence graph based on the schedule. If you get a cyclic graph, if it is having some cycle, that particular schedule is a serial schedule. If it is not getting, that is not a serial schedule. Yeah, like that, we need to check the conflict serializability, how we can with the help of this graph only. Here, that things already we discussed in the last class. Even we started log-based protocols also, right? Hello? Yes or no? Hello? We already started log-based protocols, yes or no? Hello? I need a response. We already, in the last class, we have already started log-based protocols, yes or no?
Yes, sir.
Yeah. How many logs are there basically? How many logs are there? As we discussed in the last class, basically log manager is going to provide how many logs basically? Hello? I need a response there. Please don't check my patience on Monday, please. How many logs are there? Don't waste the time. Please unmute your mic and tell, sir, how many logs are provided by our transaction management or log manager? How many types of logs are there? As we discussed in the last class. Quickly, don't waste. Fourth unit is very bigger. If you won't tell, I will end the session. How how many logs are there? Shall I end the session? If you don't want, then I will end the session. Hello? I will share this PPT, then you can read your end. For this also, you people are not responding. Hello? 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 Is this my voice is audible? If yes, my question is, here we discussed already log-based protocol. Here, how many logs are there? If you are not remembered, you ask me, explain again. Or do something. Silently means, what is the use? Shall I explain again for this log-based protocol?
Yes.
Then I am ending the session. Why unnecessarily I am wasting my time? Okay, I will put this PPT on your Google Classroom, then you can read. Thank you. Shall we continue or not?
Continue.
Yeah. Without silently, if you are simply listening, means what is the use? You at least whatever the doubt you are having, or any explanation you want, or anything you want, you ask me. Then I will explain again and again. I told you. Sure, I will explain again. Not a problem. But response is required in a voice mode, please. Right. Now, as we is this screen is visible?
Yes, sir.
This screen is
Sir.
visible.
Yes, sir.
Log-based protocol. What is the use of log-based protocol? First of all, we'll go with simple example. T1 transaction is there, T2 transaction is there in one schedule. If you take, for example, read A. Now T1 transaction is reading an object here, later writing an object here. Here as a serial schedule, after T1, T2 is started to read A. Now the problem is, here when I am going to perform T1, read A, write A, but I don't know this T1 is completed this writing of A or not. Because writing means it has to write something data on this. But same time T2 wants to read same object. If it is B, not a problem, but same object T2 wants to read. Here now that is a concurrency problem. Same time we are going to execute multiple transactions. Write A,
and read A. Same object, the two different transactions are going to perform different operations. Now, this situation, there is a chance of data inconsistency because T1 transaction is writing some data, same time T2 reading, but exactly what exactly the data contains in A object, T2 cannot be read because it is doing, but this T2 transaction doesn't know it is completed or not, writing of A by T1 transaction. So that is a big problem. Now understood? The data inconsistency how will be occur because we don't know T2 don't know this write operation is completed or not. So that it is going to read. If it is reading means maybe the continuous this writing operation is done, then data will be inconsistent. Then it is writing, but it is not completed. Again, it is reading same time. Now there is a chance of data inconsistency. Are you clear?
Yes, sir.
Are you clear?
Yes, sir.
The problem is clear.
Yes, sir.
Yeah. So that so that they implemented log-based protocol mechanism for maintaining of concurrency control. Here, concurrency control mechanism they want to implement on a schedules with help of log-based protocol. How they are going to maintain a log-based protocol to implement a concurrency mechanism? Okay, before entering with example, first of all, the concurrency control, what are the protocols they are going to provide? Basically, the log-based protocol contains two modes of logs. Here, one is exclusive lock. Here, exclusively, we are going to apply the lock on X object. That is a lock X. That is a exclusive lock. Here, another one is the shared lock S mode. Here, shared lock. There are two categories of locks. Here, what is the meaning of exclusive lock? What is the meaning of shared lock? Here, I will tell you. Here, when we are going to, why locks are required? First of all, these two locks are there. Why locks are required? I will tell you. For example, T1 is reading A and writing A. Here, when T1 performs, before that, it is going to apply lock on A object. Now lock is working on this A object by T1 so that here T1 is going to completely work with A only until unlock of A. So now you need to write lock and unlock. In between you write whatever the instructions of your transaction you do it. So that what happened? T2 never the acquire object A until it unlocks the A object by T1. So that here T2 never access the data when it is accessing by T1. So that there is no chance of data inconsistency. Here this is the help of lock. Are you clear? Are you clear? Why lock based protocol is required?
Yes, sir.
Hello? Yeah. Here, because of data inconsistency, we need to maintain because when any transaction wanted to access any object, the transaction must be applied lock on that object and perform their operations. Once the operations is done, then apply the unlock. Once it is going to apply the unlock, another transaction is going to access that object. Before that, it will be fixed the lock of A. Now T2 transaction, after unlocking, T2 transaction is locking, perform the operation, then unlock it. Next T3, next T4, like that. Yes, so that here when any transaction is going to lock any object, there is no chance of accessing of same object by other transaction. So that there is no chance of data inconsistency. So this is the basic formula about the lock-based protocol. Clear? Now clear? Hello? All of it clear now? Hello? Sir, without response, I cannot understand. All of you clear now why log-based protocol is required? Hello? Use mics,
Yes, sir.
please. Now, for that log-based protocol, here it is providing two categories of log modes. One is exclusive log, another one is the shared log. Now, why exclusive and shared logs are required? I will tell you. For example, here whatever here I am reading, all 56 students, how many are there now? 50 students are there. All 50 students are now reading, yes or no? So whatever here I have written, whatever I am displaying, all students are going to reading same or any data inconsistency from one person to another person. All 51 students are going to read this data. Is there any inconsistency? Person to person, is there any data change? Or same data you are reading all?
Same data.
Same data means there is no data inconsistency. Yes or no? There is a
Yes,
data
sir.
consistency. Yeah. There is a data consistency. There is no data inconsistency. Means when I am going to apply read operation, then if you want to apply read operation by multiple transaction, there is no problem. The same object means if this is if you take this object, the same object multiple people are going to read same time. So there is no any problem. Yes or no? Yes or no?
Yes, sir.
At a time, multiple people can read same object. There is no any inconsistency of data. Yes or no? Yes or no? Hello? 51 students are reading these contents. They are reading same content or content is changing when you are reading. I told you, respond quickly, answer the question. Hello, are you sleeping? All of you sleeping? Hello. I'm asking here, all students are reading this data. Everyone is reading same data or any data is going to change.
Same data, sir.
No change, sir.
No change. If no change means when we are going to perform read operation by multiple transactions, there is no data inconsistency. Correct?
Yes, sir.
Is it correct? Means we can apply read operation concurrently. Correct? There is no data loss. When I want to apply a read operation concurrently, there is no data loss. Correct? Quickly, if I apply read operation on same object by multiple transactions, so there is no data loss. Correct? Hello. If I am going to apply read operation by multiple transactions, there is no data loss. Correct? What you people are doing? Tell me now. What is going on? If you don't want, tell me. I will end the session. You know, next month, 15th onwards, people are having mid examination, second mid. I am going to finish the syllabus. You people are doing this nonsense. How can I continue? Already 25 minutes are done. Simply, what you are doing? Same thing I will do that. When you are going to ask any problems or any things you are going to face for your things, same thing I will do it. Then you can understand what is the problem is going on. How many times I can tell? I can ask the question, same question repeatedly, repeatedly. Are you using your brains or not? Tell me. Don't waste the time. Here, when we are going to perform read operation by multiple transaction, then is there any data inconsistency? Is there any data inconsistency?
No, sir.
If no, then this read operation we can apply for at a time multiple transactions. Yes or no? Concurrently.
Yes.
Yeah. If it is yes means, yeah, yes means when I'm going to apply read operation, before that we need to apply shared lock. So that is a shared lock. That is a lock S. Yeah, before, if you want to read any object, only you want to read any object, before reading of that object, you must be apply shared lock, because shared lock is going to tell data item can only be read. Shared lock is required using lock S instruction, because when you are going to perform read operation, there are multiple people also going to perform, so that we can share that object to multiple transactions. So that you can go for shared lock. Because already I told you, any operation you want to perform, compulsory you need to apply the lock. Here, which lock you need to apply, that is depending on your operation. If you are going to read the data, so that you go for shared lock, because here reading operation is, there is no data inconsistency for multiple transactions. Now clear why shared lock is required, when shared lock is required? All of you clear?
Clear, sir.
Yeah. Next one is the exclusive lock. Means any transaction want to write some data on a object. Means here, before performing any operation, we need to apply lock. Which lock you need to apply? Exclusive lock. Why exclusive lock is required? Here, exclusive lock on A. Why exclusive lock are required? Here, when someone is writing, now you are going to read same time. The data inconsistency will come or not. So sometime I am writing, then same time you are reading. So now I am writing, you are reading. Then data inconsistency is there or not?
Yes, sir.
So that when any transaction is going to write data on object, here you need to apply exclusive lock on that particular object, so that that object is available exclusively for the transaction. Then they can perform the write and read operation. The exclusive lock is going to provide for write and read operation. But when we are going to fix this object with exclusive lock, no other transaction can be accessed. But when go for the shared lock, here n number of transactions they can access with read operation. But when go with the exclusive lock, only that transaction is going to access that particular object for write and read operation. If that is the case, we can use the exclusive lock. Now understand? All of you understand?
Yes, sir.
Yes, sir.
Now tell me, how many locks are there for lock-based protocol?
2 lakhs.
Exclusive lock and shared lock. Here, when you want to perform write and read operations exclusively for one object, you need to apply exclusive lock. When you perform only read operation by multiple transactions, you can use shared lock. Clear?
Yes, sir.
Means in this context, if you are going to observe, when you use shared lock, we can achieve concurrency. When you use exclusive lock, we can achieve serializability. Means when multiple reads are there in the same time, you can perform, you can get the concurrency. When write operations are there, only write operations are, then you go for the exclusive lock, you can get the serializability. So that we can manage the concurrency control manager for this lock requests. Here, whenever I want to perform any operation, automatically we are going to request to the lock manager. The concurrency control manager is going to release the particular lock, which is exclusive lock, either shared lock. Like that, we need to apply this locking based protocol with the help of these basic two locking mechanisms. All of you clear? Now all of you
Yes,
clear?
sir.
Right. Now coming to the log-based protocol, how we are going to apply? Yeah, this is a compatibility matrix. Already I told you just now. When shared and shared means multiple transaction one, transaction two, like that. Here shared and shared log. Here it is a true or not. Multiple transaction they can use shared, right? There is no any problem, right? Hello.
Yes, sir.
One transaction is applied T1 as a shared lock. Here T2 also you can apply shared lock. That is a true. Understand?
Yes, sir.
Here one transaction is applied exclusive lock. Here another transaction you want to apply exclusive lock. Here it is shared lock. Another transaction want to apply exclusive lock. It is false. Because already I told you, only shared share will be applicable any number of transactions. There any other transaction will another operation means except that read. If you want to write exclusive means write, then it is not possible. That is the truth table is false. Correct? Yes or no? I am reading, then you are started writing. But my data is inconsistency, right? Because you are updating. Understand? Hello?
Yes, sir.
Now same T1 again applied exclusive lock and T2 shared lock. Is it possible? As per the discussion, T1 is applied exclusive lock. Now I am trying for shared lock on same object. Is it possible?
No, sir.
No, false. Again, T1 is applied exclusive lock. T2 is trying to apply exclusive lock. Is it possible?
No, sir.
No. Only when we are going to perform read operation by multiple transaction on same object, that is only possible. Remaining all the cases, it is not possible. Here, this is the log-based compatibility matrix. Very important. All of you clear this? All of you clear this? Yeah, this theory also same. A transaction may be guaranteed granted a lock on an item if the request lock is compatible with locks already held on their items by other transactions. Any number of transactions can hold shared locks on an item. But if any transaction holds an exclusive on the item, no other transaction may hold any lock on the item. Just now I told you. If a lock cannot be granted, the requesting transaction is made to wait till all incompatible locks held by other transaction have been released. This the lock is in the granted. Here, this is what exactly the lock-based protocol and lock compatibility matrix. All of you clear? This theory already I explained everything with this example. All of you clear? All of you clear this?
Yes, sir.
Clear.
Yeah. Now, when we are going to observe with one example for log-based protocol, please observe this example. You can understand very easily. Now, T2 transaction want to read object A. Here, before that, already I told you, before that, you need to apply lock. Which lock we need to apply? I want to read. Which lock we need to apply before this? Tell me. So, I want to read object A so that which lock we need to apply before reading of this A object?
Shared lock.
Because we are reading only, so that we need to apply shared lock. Compulsory. Here, any operation you want to perform, compulsory you need to apply lock in a lock-based protocol. After completion of your job, you need to unlock that lock. That is also very important. Here, after completion of read operation, now I am going to unlock A. Whatever the lock I applied, that is going to unlock. All of you clear? All of you clear? Hello? All of you clear this?
Yes, sir.
In the same way, again, object B, I want to read, so that before that you need to apply. For reading purpose, shared lock you need to apply. After completion of this, you need to unlock. So this is what exactly the lock based protocol when we are going to use. Here, before performing any operation, the suitable lock you need to apply. Locking as above is not sufficient to guarantee serializability. If A and B get updated in between the read of A and B, the displayed sum would be wrong. Any changes is going to happen in between A and B, then this display will be wrong. But when your locking mechanism is perfect, then compulsory there is no chance of changing, then automatically the A plus B is right. Now a locking protocol is set of rules followed by all transactions while requesting and releasing locks. This is very important. This is a requesting lock, and this is a releasing lock. So this rule must be followed. All locking protocol restrict the set of possible schedules. Then only it will be done. If you forgot to unlock of that particular object, then what is the meaning? If you have not written this object, then what is the meaning? Here the T2 transaction is applied shade lock on S, it will be continued. So if you are not released a lock, so the lock is continually it is available on this particular object here. So no other transaction cannot be accessed. So that once your operation is done, you need to release. For example, we are conducting the classwork as per the schedule, the timetable. Once my time is over, then I am going to release my lock so that you are going to attend another class. Same way, this transaction also, when you are going to use the log-based protocol, here before performing any operation, you need to apply related log. After completion of the transaction operation, then you are going to unlock the things. So these two things are very, very important. If you are going to miss, then what will be happen, we will discuss. So that is what exactly you need to follow. All of you clear? All of you clear? Lock, unlock? Hello? Hello? All of you clear about this? Locking and unlocking. Hello?
Yes, sir.
Now, when we are going to perform a locking based protocol, there is a pitfalls, means there is a drawbacks. So, what are the drawbacks are there? So, please carefully observe. You need to tell now, then only I can understand. The T3 transaction want to read, so that it is going to apply one lock. But same time, B object T3 transaction want write also. Here both operation want to perform by T3 operation. Here before that, what lock we are going to apply? Tell me. On B object. Hello. Which lock we are going to apply on B when I want to perform read and write operation on B object? Hello. Are you watching? Are you listening my class or not? Now tell me which lock I should apply.
Exclusive lock.
Why exclusive lock is going to provide exclusively on B object so that you can read and you can write. Right. Okay, good. Exclusive lock I applied. So now T3 applied exclusive lock. Then T3 is reading that B data and it is writing B minus 50. Okay, done. Now T4 is going to start. Now T3 transaction is over. Now T4 wanted to start. Now T4, now the T4 transaction wanted to read object A, so that it is going to apply shade lock on A. Okay, good, no problem. Now it is reading. Then again, now T4 transaction wanted to read data, so that the T4 transaction wanted to apply shade lock on B. Now when it is going to apply shade lock on B, so A is different object, that's why it is not never depending on A4 or A3. But when we are going to perform any operation on B, compulsory B is already locked by T3, because here we have applied exclusive lock on B, read B, write B. But here we are not released the lock. Yes or no? Yes or no?
Yes, sir.
If you are If you are not released the lock means your T3, even T3 working continuously on B object. So that when T4 trying to access this particular B object, T4 has to wait until T3 is going to release the lock on B. Yes or no? Yes or no?
Yes, sir.
Now, again, T3 wanted to access A object and T3 wanted to update the data on A object. Now it wanted to lock, exclusive lock on A. But here T4 transaction also applied shared lock on A, but it has not released a lock on A. So that again T3 also going to wait until T4 is going to release the lock on A. Yes or no?
Yes,
Yes
sir.
or no? So that here T4 is waiting for T3 continuously because we don't know how much time it is going to take and release the lock on B. And T3 again waiting for T4 because of this lock. So now this is a problem, this is a pitfall. Yes or no? Problem or not? For example, I forgot I am continuing my class. Till 3 o'clock I have not released you. Here I am continuing. Next class faculty is going to wait until I am going to release the lock. I am going to end the session. So that is the big problem. Yes or no?
Yes,
Yes
sir.
or no? Yeah, this problem is called as, this situation is called as deadlock. Very important. Same deadlock mechanism you people are having in the operating system also. One process is working on one object, remaining processes are waiting until the process is going to release that object. So that is called a deadlock. Are you clear? Are you clear now?
Yes, sir.
So already I told you operating system and here one unit is same, but here we are talking about the transaction, there we are going to talk about the process. Right. Now deadlock is nothing but simple. Neither T3 or nor T4 can make progress executing shared lock on B causes T4 to wait for T3 to release its lock on B, while executing exclusive lock causes T3 to wait for T4 to release its lock on A. Here, such situation is called as deadlock. Here, this is a deadlock. Here, when you wanted to overcome this deadlock or handle this deadlock, we need to go for rollback. Here we are going to roll back here, again we are going to roll back here. Again go back, go back, go back. Again you need to do, again go back, you need to. Means rollback is required again. Here as per the discussion, we are going to avoid the rollbacking mechanism to implement the concurrency. But if you are not prepared your schedule perfectly, locking and unlocking mechanism, then again the deadlock is going to happen because of your schedule preparation is wrong. That is what is carefully listen. If your schedule is good, then there is no chance of deadlock. If your schedule is implemented in a bad way, then there is a chance of deadlock. If the chance of deadlock is there, again we need to apply rollback. The rollback is again the time wasting and time consuming process. Again, it is not suitable mechanism for the concurrency mechanism. Clear? Clear now? First pitfall, drawback of log-based protocols. First one, is it clear?
Yes, sir.
Now next one is the, if your deadlock is continuous, means you are not solved this deadlock. So the potential for deadlock exists in most locking protocols. Deadlocks are necessary evil. So this problem is continuously arising, continuously. Even we are not solving this deadlock problem. So this is continuously happening. So that is called as starvation. It is also possible if concurrence control manager is badly designed. If this design is bad, this type of deadlock problem will become continuously for this concurrency mechanism. So that situation also called as starvation. Are you clear? Are you clear?
Yes, sir.
Yeah, so that the concurrency control manager can be designed to prevent starvation. Now the concurrency control manager is going to take care and design the schedule to avoiding of this particular starvation problem in a schedule. So these are the two problems. One is deadlock. Because of the deadlock continuously occurring, there is a chance of starvation. To avoiding of these two problems, our concurrency control mechanism is going to implement a good design so that we can avoid the starvation as well as the deadlock. All of you clear? All of you clear log-based protocol and the pitfalls, nothing but drawbacks of log-based protocols?
Yes, sir.
Yeah. So that our concurrency control mechanism is implemented two-phase locking protocol. Here, because of these pitfalls, that is, one is deadlock, another one is the starvation. To avoid that, our concurrency control manager is designed a one good mechanism, that is two-phase locking protocol. Very important, the two-phase locking protocol. Then what is the meaning of this two-phase locking protocol? Two-phase locking protocol contains two phases. There are two phases. Here, the first phase is a growing phase. The second phase is a shrinking phase. So what is the meaning of this growing phase? Means increasing of the log. Growing means increasing of the logs. Shrinking means decreasing of the logs. Please carefully understand my words, then the things are very easy. Here, two-phase locking protocol contains two phases. The first phase, we are going to achieve more logs. Here, in the second phase, we are going to decreasing the logs, shrinking the logs. So these are the two things you must be remember. Means in first phase, if you are in a first phase, then always you go for the locking. Next, every time you need to lock. Don't go for unlock. You're coming to the shrinking phase. Second phase, if you are achieving your transaction, then always you need to remove the locks. Don't take any new lock. These are the two-phase mechanism we need to use. We can achieve the good mechanism comparatively previous one. Now understand the meaning, general meaning. All of you two-phase locking protocol. All of you understood? Hello?
Yes, sir.
Right.
Yes, sir.
Now, for that, what it contains in a growing phase? Very simple. In a growing phase, transaction may obtain lock. Only it is going to obtain the lock. Here, may not release the lock. Here, never. Here, in this phase, the locks is never going to release. Compulsory, it must be obtained. Obtain, obtain, obtain. No, there is no chance of releasing of the lock in the first phase. Clear? Clear?
Yes, sir.
The second phase, shrinking phase, means transaction may release locks. Here, in that case, the transactions are releasing the lock only. Here, there is no need to obtain locks. Here, it never going for new locks to obtain. Here, always it will be concentrate on releasing of the lock. Clear?
Clear, sir.
Hello? Hello? All of you clear?
Yes, sir.
So here using this two-phase locking, we can achieve the serializability. How? Means in a first phase, what happened? For example, if you take T1 transaction, in first phase, what will do? You're only growing phase. In second phase, what will do? Only shrinking phase. So that's why here serializability. Here first it will be do, next it will be do. That's why they are growing and shrinking, growing and shrinking. If you take T2, again growing and shrinking. Here n number of transactions you take, the first phase must be a growing phase, means obtaining the logs. It never release the logs. Here second phase is shrinking logs, nothing shrinking phase, nothing but you are going to remove the logs, never obtaining the logs. So that we can achieve this protocol, you can achieve serializability. It can be provided that the transaction can be serialized in order of the lock points. So this is what exactly the in-depth meaning of two-phase locking protocol. Very important. All of you understood? All of you understood?
Yes, sir.
Now, in this two-phase locking does not ensure freedom for deadlock. Exactly. Because here we are just applying initially all locks. Here next phase we are going to remove all the locks. So only these two things we are going to do. But how we can ensure the deadlocks we cannot achieve? Because the T1 transaction is performing something on object queue. The T2 transaction want to perform some operation on same object. This time there is a chance because the T1 is already applied lock, now T2 has to wait. Yeah, that is a compulsory. Maybe first phases it is going to shrinking, growing, and second phase shrinking. Not a problem. But the problem is deadlock. So this deadlock we cannot be avoid. Are you clear? In even two-phase locking, we cannot avoid the deadlocks. Are you clear? Hello? Hello?
Yes, sir.
So, if we are not avoiding the deadlock, then there is a chance of cascading rollbacks. Because if there is a deadlock, we need to roll back, right? Compulsory. Simple. Means the meaning is two-phase locking is that in this phase, we need to do only growing phase. That in this phase, you need to shrinking phase. Like that, any transaction you have to perform, the one phase is growing, another phase is shrinking. But there is no avoidance of the deadlock. If there is no avoidance of the deadlock, if any deadlock will occur, then you need to roll back. That's why when using this two-phase locking, there is no chance of deadlocks avoidance, so that we need to use rollbacks, and we can apply two-phase locking with rollbacks, so that only we can solve the deadlock problem. Yes or no? Yes or no? Hello? Yes
sir.
or no? Yeah. Now, here in this mechanism, in this two-phase locking mechanism, they are implemented based on this two-phase locking mechanism. They are giving some more extra rule, and they are implemented a two-phase locking into strict two-phase locking protocol. Here, what is this strict two-phase locking protocol? Means here a transaction must hold all its exclusive lock till it commits or aborts. Means in a whatever the transactions two-phase locking you are performing, the first phase is what? Only growing the locks, right? Yes or no? Hello?
Yes, sir.
Only growing the phase. But in a strict two-phase locking, then in that growing phase, all locks must be exclusive. So whatever the locks we are obtaining, so it contains only exclusive. There is no chance of shared lock. There such type of locking protocol is called as strict two-phase locking protocol. Clear? All locks must be exclusive. Such locks are called as strict two-phase locking protocol. Clear? Hello? Hello?
Clear.
Yeah. Now, rigorous two-phase locking protocol. This strict two-phase locking is extension of two-phase locking. Don't confuse. Sometimes people will ask. Here, again, the extension of two-phase locking is rigorous two-phase locking protocol. Here, even it is more stricter than strict two-phase locking. Here, all locks are held till commit or abort. In this protocol, transaction can be serialized in the order in which they commit. Here, in this rigorous two-phase locking, all locks means along with exclusive and here shared locks also will be applied until commit the transaction. Here in this two-phase, strict two-phase locking, only exclusive lock will be there until commit. But rigorous, here both shared and exclusive locks must be achieved, must be there until commit or abort the transaction. But coming to the two-phase locking, here only first phase you are going to apply the locks, second phase is going to shrink the locks. Here never we are concerned about the commit or abort the transaction. But coming to the strict two-phase locking, until commit or abort, all exclusive locks must be hold. Means there is no removing of the exclusive lock. The rigorous two-phase locking, until commit or abort, all Shade lock and exclusive lock must be hold. No lock is going to release. So this is a rigorous two-phase locking. Are you clear? The remaining things are same like two-phase locking. Means after that, then you go for the second phase is shrinking phase. All of you clear this two-phase locking? Hello?
Clear, sir.
Hello? Yeah, stick to two-phase locking and rigorous two-phase locking are also clear.
Yes, sir.
Now, this slide is last slide. Today's very important. Go for the two-phase locking. So there can be conflict serializable schedule that cannot be obtained if two-phase locking is exactly. If you are used a conflict serializable schedule for your transaction, then we cannot use this two-phase locking on this conflict serializable, because conflict serializable means those S and S dash must be equivalent schedules. If it is equivalent schedules means that there is no chance of this two-phase locking protocol. Means two-phase locking protocol means always the first phase must be growing phase, second phase must be shrinking phase, so that it is not possible. The absence of extra this mathematics, given a transaction Ti that does not follow two-phase locking, we can find a transaction Tj that uses two-phase locking and a scheduled Ti and Tj that is not conflict serializable. Okay, that is another information not required. Now, all of you understood the two-phase locking protocol and its supplementaries of strict two-phase locking and rigorous two-phase locking. All of you understood? Hello?
Yes, sir.
Yeah. So in the next class, we will go with lock conversations and how the locks are going to achieve, and how the we can apply locking protocol and validation based